Come on. There we go. So we found the equation for f of x, and remember the way we did it graphically is that we found the y-intercept was at -1, and then you can either find the slope by finding two nice points on the function, and by that I mean it doesn't do something like this where it doesn't cross in a crosshair, but two nice points, and you can either actually use the slope formula or you can count over and up, and that becomes your change in y and change in x. However many you go up or down is your change in y. But note, if it's down, it would be negative. So if you're going down, it would be negative. And then your across would be your change in x. And if for some reason you count to the left instead of to the right, if you count to the left, that would also count as negative. I usually always count to the right and then just make my y values the thing that could be positive or negative, but whatever floats your boat. So last time we found that equation to be x minus 1. So what I'm going to have you do is we're going to jump over to Desmos. So what you're going to do is you're going to jump over to a different tab. Well, you might want to write down the code like next to you or something. But you're going to need to go to student.desmos.com. And then it's going to ask for a code. So the code's going to be BANXT5. It is not case sensitive. So if you put it in capitals or not, it'll accept it. You can log in with Google or not, whatever floats your boat. If you feel like you might want to come back to this later, I would probably suggest logging in because you can come back to this. It's pretty nifty. But otherwise, go ahead and try to get in there. Do put in your name. I am going to anonymize all of you, but just in case I want to go back and look at it, put your name in there. You'll only be able to see the first 4 screens so far. So I know there are 10 screens, but you'll only be able to see the first 4. And essentially, it's just going to be this problem. But you guys are going to go through and write the answers out. The one thing that I don't like about Desmos is that you can't press enter to move down to a new line when you're putting in an answer, specifically in math mode. So some of these slides have multiple questions on them. You'll just kind of have to smush them all on the same line. So try to answer those. I will give you like, I don't know, I'll maybe give us 3 to 5 minutes so people can get in and then look them over. So the first one we've already done. So you will need to figure out what g of x is, but we already figured out what f of x is. Put your answers in on there. You will see your classmates' answers popping up as well. So if you're really stuck, you can try to look in off of theirs and see if you do look at theirs, don't just look at it and move on with your life. Try to make sure that you understand why that's the answer. But you will see their answers. Don't worry, you all have random, mathematician, scientist names, so no one will know it's you, unless I change it back. So I can know it's you if you're gonna write silly stuff. But anyway, go ahead, try that. I'm gonna stop talking for a little bit. Try the first 4 slides, and then we'll talk about them really quick, and then we'll keep going. Give you maybe about another minute. So there are 3 sets of questions that you should be answering on slides 2, 3, and 4. Some people are done, some people are just sitting on the first one. You know, I can see y'all. It's fun because it lets me snoop. Okay, just another couple seconds, and then for the sake of time, we'll move on. Well, we'll talk about them, and then we'll move on. All right, for the sake of time, let's go ahead and jump back over. Just pull up your team screen again. Let me see what some of y'all said on these. Looks good. Okay, some of you just ended up doing all of them on the first one. Okay, that's okay. Okay, most of these submissions look really great. Okay, so we did f of x the other day, so we're moving on to g of x. So g of x is that horizontal one up there. So it crosses the y-axis up at 2, so you have a y-intercept of 2. And then your slope, if you look at your change in x over change in y, your change in x could almost be anything, but let's just maybe just take a shift of 1. But your y values don't move at all. So we would have a slope of 0 here, 0. So your g of x equation should have been 2, or if you wrote 0x plus 2, that's perfectly fine. But most of you wrote g of x equals 2. Perfectly great. Awesome. Good job. That's what it is. If you missed it, don't worry. Just make sure that makes sense before we do the next one. So then let's see what somebody else said about h of x and j of x. Good, 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 good. Good, 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 good. Good, good, lovely, amazing, awesome. So h of x was our only one that was going downwards. So it crosses the y-axis at the origin. So we will have a y-intercept of 0, and then our slope here. We would have to be careful if we're doing graphically. The next nice point is actually 2 over, so you would go over 2 down 1. So we would have a slope of down 1, right 2. So the slope would be -1/2. So the equation you were looking at was -1/2 x. If you want to put 1/2 x plus 0, that's also perfectly right. Whatever floats your boat. So let me kind of box these answers in case someone's looking at this later. And then j of x, the last one. I know I'm going through these kind of quick, but that's because hopefully you had already looked at it. As always, feel free to stop me. Why is this yelling at me? Oh, my laptop is angry. One moment, please. There we go. So the last one, j of x, crosses the y-axis at 1, so we have a b-intercept of 1. And our slope, if we're going to the next nice point, it would be up there, so we go over 1, up 3. So our slope would be 3 over 1, which would be 3, so our j of x equation should be 3x plus 1. Which again, most of you had, which is awesome. Because you don't see my screen, but I see all of your answers. All right. Oh, and then there's the last question. Good, 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 good. Also great on this one. Okay, so the last batch of questions was essentially asking you questions about those. So which function or functions has a negative slope? There was the only one of them, which was h of x with -1/2. Which function has the highest magnitude of slope? If you aren't familiar with the word magnitude, that's essentially the largest number in absolute value. So like -4 has a higher magnitude than +3 because the absolute value of -4 is higher than 3. But in this case, it was actually the highest positive number as well, which was 3. So our j of x was the largest magnitude. Which function has a slope of 0? There was only one of them with a slope of 0. Remember, your slope is your m value, so that was g of x. greatest vertical intercept was at +2 for g of x again. And then the smallest vertical intercept is at -1. So that would have been f of x. Questions, concerns on that question at all before we move on to the next one? All right. So what I've done is I've now opened slides 6 to 9. So pop back over to your Desmos. And try slides 6 through 9. This might take a little bit more time, so I'll maybe give us 5 to 7 minutes on that. Some of them take a bit more time to look over. But go ahead and try to answer those. Do the best you can. Some of them might need a little bit of thought, but try your best. If you aren't sure, just put what you think and we'll go over it in about 5 minutes. So it'll be problem 6. So at the top of the screen, it should say problem 6 or potentially problem 6 continued. So that starts on slide 5. Also, just in case, make sure you realize you can go to the next slide. There's like a next button in the top right corner. Some of you are sitting on the first problem, and I don't know if it's because you're just sitting there because you want to, Because you don't know, you can go on to the next one. So I'm kind of pressing the right buttons on the team screen if you want to pop back and look at it real quick. All right, maybe another 2 minutes on this before we pop back and talk about them. All right, take a few seconds to finish what you're typing and then pop back over to the Teams thing so that we can see the answers written down. So of course this first one, hopefully everyone got, because it's essentially just regurgitating definitions. So we got our y minus y1 equals mx, minus x1. So our m's our slope. Our y1 is our y value of the point. And of course the x1 is the x value of the point. Slope intercept, y equals mx plus b. There you've got your slope and your y-intercept. And then your y2 minus y1 all over x2 minus x1. I'm not going to label that one. It's just the points. So, scrolling past that one super quick, because again, those were just questions. So let's see. How'd everyone do on this one? Looks awesome. So this one, it just sets it up for you, because if you're looking for y equals mx plus b and they give you your m and your b, you just got to plug them in the right spot. So your slope was -4 and your y-intercept was 3/2. If you were to change that to a decimal, perfectly fine. Most of you kept it as a fraction. Equation of a horizontal line passing through -4, 7.3. So that's going to be, some line up here. That's going to have an equation y equals 7.3, which most of you seem to have, which is awesome. One thing just for note purposes, so horizontal lines are always going to take the form y equals some number. So if it's a horizontal line, it's always a y equals something. And then looks like everyone pretty much got the other one too. Vertical line passing through -13.5, that's going to be some vertical line back here. So we will have x equals -13, and any vertical line will always take the form x equals some number. Now, one thing I do want to note about that one's not a function by any means, because it doesn't pass the vertical line test, because it's literally a vertical line. Because essentially that input of -13 has infinitely many outputs. So it's not a function, but we can still draw it, we can still talk about it, it's still used every once in a while. It's just not as used as other lines. Part G was probably the one that took the most thought, because you actually have to put a little bit more work in here, but looks like most people got that one right. Does look like someone might have flipped the slope by accident. So here we essentially have 2 points, 1, 4, and -2, 13. So our slope would have been 13 minus 4 or 4 minus 13. I just like putting the larger y value first. So 9 over -3, you'd get a slope of -3. If you plug that into y equals mx plus b, I would personally pick the 1, 4 to use for that. But it doesn't matter which one you pick, you'll get the same b value. You end up that b is 7, so your equation should be y equals -3x plus 7. Which again, most of you have. Which is why I'm going through it so fast, but of course, stop me if you need to. And then this last one, we essentially have a horizontal line at 2 and a vertical line at -3/4. So the intersection point is essentially just going to be at those two values, at the x value of -3/4 and the y value of 2. And most of you got that as well. Awesome. Questions, concerns on any of that question? Going once, going twice. Sold to no one. Okay. As always, you can have me go back later. I will open this up in just a second, but I want to explain it first. Boink. So the next thing you're going to see once I open it up in a second is a bunch of little cards. Now I believe there's a way, maybe I can't do it while it's in tablet mode. Yeah, if you double click on a graph, it'll expand it if you need. Oh no, bye. Oh, sorry, for leaving, you're coming back. Hi. So if you need to expand it, you can double click it. Hopefully the red plus the dashed lines make it make sense. Anyway, so essentially note that these are super generic, but they are all positive numbers, these A's and B's. So essentially like this one right here would be a positive slope, a positive y-intercept. So you'd be looking, okay, well, which one of the lines has a positive slope, has a positive y-intercept? I'm going to pair it with that one. I didn't pair it with the correct one, but you're going to pair them together. You essentially just shove them together and then they match. And you can also do this if they start to get in the way a lot. But that's going to be your next thing. It's going to be a little card sort. So it is open now. So go ahead and try that. So you're trying to match the generic equation with what graph it would be. So I will give us 3 minutes. I'm going to go a little shorter on that one. Let's go 3 minutes on that one. We'll write the answers down in our notes and we'll move on with our lives. Got only 3 people who've gotten everyone correct. Ooh, 4. A couple people who have a couple that are mismatched. Mismatched. Give you another like 30 seconds. All right, let's go ahead and pop back over. You will see my Desmo screen. I'll go over the answers that way real quick before I just write them down on our notes. So I'll give you 5 seconds to jump over. So I've got them arranged a little bit before I'm going to sort them. So kind of my first column, just the graphs, not the equations, are my negative slopes, and then I have my weird ones, and then I have my positive slopes kind of grouped at the right. So let me start with these weird ones, the second column in. So remember, on the last question, we just found out that a vertical line, that's not vertical, a horizontal line, a horizontal line is always going to be a y equals, and it has to be y equals without an x in it. Okay, that's the point. So the only one that has y equals and then doesn't have an x in it is actually this y equals a plus b. It's kind of tricky because it's got the addition in there. They kind of trip you up a little bit there. But that one would match with that. And then our vertical line, vertical line always takes the form x equals something without a y in it. So the only one that has x equals without a y is this x equals 2b. And then let's see. So let's group. We've got negative slope equations and we've got positive slope equations. So let's look at the positive slopes first. So notice that only one of them doesn't have a y-intercept, or would have a y-intercept of 0, that a over 2x. And there's only one graph that has a y-intercept through 0, so that a over 2x would match with the one that goes through the origin. And then these last two, they both have a positive slope, so ax, but then it depends on whether or not it's a positive or a negative y-intercept. So the one on top for me is the positive y-intercept because it intersects above the x-axis, it intersects above the x-axis, so it's a positive y-intercept, where the other one intersects below the x-axis, so it's a negative. And then our last two are our negative slopes, so we have our negative bx's, and then we have a positive a, which is going to be our positive y-intercept, and a negative a, which is going to be our negative intercept. So that's how they would have matched on Desmos. Not necessarily in that order. Your screen would have looked different than mine, possibly. But don't worry too much about getting the Desmos set up correctly. Like, not really going to look back on it or anything. But I'm going to write down the answers, on our notes real quick. So that it's the exact same problem, we just didn't have the lettered pieces here. So if you did do them by the paper, it's essentially the same reasoning. The y equals a over 2x goes to the one that crosses at the origin, and so on and so forth. Questions, concerns about that question? All right, so we won't need Desmos anymore, so you can either close it out or just leave it there and close it out later. So stay over here. So that was the end of our Desmos. Hopefully it wasn't the worst thing you've ever done in your life. So we've got one more question in this section we've got to talk about, and then hopefully we'll have maybe just a tiny bit of time to start 1.3, maybe get a first definition in there. So our last question in this section, suppose a new MyPhone cell phone costs $650 and depreciates in value by $30 per month. A new Cyborg costs $580 and depreciates by $25 per month. So let m of x be the value of the MyPhone x months after it was purchased, and c of x be the value of the Cyborg. Write formulas for mx and c of x. So essentially the two things we need to notice is we need to notice that they have a starting value and then tell us essentially how much it's changing over time. So the starting value is essentially going to be our y-intercepts. So we have mx for the MyPhone started at 650, and then the c of x for the Cyborg. Super cool names, right? It started at 580. And then since it depreciates, it's going down in value. So that's essentially going to tell us that that's going to be a negative slope. So for the MyPhone, it was depreciating at $30 per month. So we'll have minus 30x and then minus 25x for the Cyborg. Say Carrie and Miranda buy phones at the same time, and because we want to match letters, Carrie's going to buy the Cyborg and Miranda's going to buy the MyPhone. When will their phones have the same value? So since the value of the phone is the m of x or the c of x, we essentially want those two values to agree with each other. So we want to set these two equations that we just created equal. And now we just got to do a little bit of algebra. I personally like trying to make the x values positive, so I would personally add the 30x over to the other side first. And then subtract the 580. We'll end up with 70 equals 5x. Divide both sides by 5. Get 14. X value is in terms of months, so this is essentially telling us after 14 months. 14. They will have the same value. And then for the last piece of this question, how many months, after how many months are each of the phones worth nothing? I'm going to split this up. So we essentially take both of those equations separately, set them equal to 0 because we want their value to now be nothing, so to be 0. So add the x valued thing over to the other side, divide by its coefficient. So 650 divided by 30 will give us 21.6 repeating. If you would like to, truncate that to 21.67, that's perfectly fine. And then for the other one, we add 25x to the other side, divide both sides by 25. We'll get x is, my notes, what is it? 23.2. So essentially for the my phone, it'll be after 21, and I'll just say 2/3 months. I usually don't like using fractions, but. And then for the Cyborg, for the other one, come on, go back. It was after 23, and since I made the other one a fraction, I'll make this one a fraction too. 23 and 1/5 months. Any questions on that set of questions? Okay. So leave that up for a couple more seconds in case people are still getting stuff down. But we are going to move on to the next section. We don't have too much time, but we'll at least get through this first definition and maybe 1 or 2 problems. So we'll go there in about 5 seconds. Oh, just a reminder. So there are other questions here, but remember, those are the extra ones. I'll be writing the answers out and putting them on Blackboard in case you want some extra practice for this section. Completely optional. Don't feel like you need to do them, but they will be there if you want them. So our next thing that we have to talk about is average rate of change and relative change. So at this point, we've been doing a lot of algebra review. And well, this is still technically algebra, but we're slowly creeping into the pre-calculus material to then finally be able to reach the calculus. So we're going to skip the warm-up. We'll do that on Monday. So, definition. If y is a function of t, that is y equals f of t. Remember, that phrasing is going to come up a lot. Is a function of. So we have y equals f of t. Then the average rate of change of y between x equals a and x equals b is the following. F of b minus f of a all over b minus a. This is usually what people will write when they write the average rate of change. But note that I also put a change in y over change in x. But wait a minute, that's slope. Yes, it is. So I do want to be clear, the only difference is semantics. So if you're wondering why this is exactly slope, but we're not calling it slope. When I say the word slope, I want to be careful how I phrase this. This is specifically talking about like a linear function, a straight line. For the average rate of change, it is talking about a line because it's talking about a line between 2 points, but it's used in broader contexts. So say I have, a parabola. I could ask you the average rate of change between the 2 points that I've just created, and technically the average rate of change would be telling you the slope of the line between those 2 points. So yes, it is a slope, but we refer to it as an average rate of change instead of a slope because it's in the context of a nonlinear function. Semantics, if you call it slope, I will understand what you mean, but you can think of them as pretty much very synonymous. Average rate of change is a slope. So the units of the average rate of change are the units of y per the units of t. Is exactly how the units of a slope went. So we've got 5 more minutes, so we should be able to do this first example at least. If not, maybe the second one. But let me try to keep that in there a little bit and just squeeze that in. There we go. So let's say g of x is x cubed minus 2x squared. So a graph, part of the graph, is shown right there. We want to draw a line segment between the points on the function where x equals 0 and x equals 3. So x equals 0 be right here. Let me do this in a different color. Blue. Oh, that's okay. And then x equals 3 is kind of the very end of that graph there. Let me make this thinner. So the line between those 2 points would be right there. So what is the connection between the line segment and the average rate of change? So I actually kind of already spoiled the answer to this question. So that line segment, so the slope of that line segment is the average rate of change I'll even say for g of x, the specific function we're talking about, between x equals 0 and x equals 3. So again, a very close relationship between the two things, but different contexts, so different wording. But the slope of that line segment is the average rate of change for that nonlinear function. And so we will do one last one. I'll hold on a couple seconds before we move on to that one, but so let's calculate one real quick. So let's consider the function 1/16, excuse me, x to the 4th minus x squared, which is graphed below. Evaluate each of the following, then interpret as an average rate of change of g of x over some interval. So let's just do the first two and we'll finish the other one. That'll help us get back into it on Monday. So this first one, if we plug in 0 to that function, so we essentially have, now I know there's not a ton of space here, so we need to be a little careful. So if we plug in 0 into this function, we're going to have 0 minus 0. So that's going to give me 0. And then if I plug in -2, we'll have 1/16 times -2 to the 4th minus x squared. Sorry, minus -2 squared. So let me kind of make sure we're being clear about that. So g of -2 is 1/16 -2 to the 4th minus -2 squared. If you plop that into a calculator, because I can't do that in my head, it's apparently -3, according to my notes. And then in the denominator, we have 0 minus -2, so essentially 0 plus 2, so we'll have 2. So we'll end up with 3/2. And what that number is actually going to represent is this is going to be the average rate of change, and I usually never write it out. I will usually abbreviate that as average ROC. So the average rate of change between x equals 0 and x equals -2. You could write -2, 0. It doesn't matter which order you put them in. But since those are the numbers that were used in this format, that's the average, the thing that we're taking the average rate of change between. And I'm actually going to answer part B for this part, because for part B it says draw a line segment on the graph that corresponds to the rate of change. So if we wanted to draw a line segment for this one, I'll do it in blue. We have the point at 0 and the point at -2. So if we draw the line between those 2 points, and I'll even write slope is 3/2. So that's how we're going to be calculating these, is that we're essentially taking the values we want to take the average rate of change between and then essentially finding the slope between those 2 points, but it's usually written as an f of b minus f of a all over b minus a, or in this case, g of b minus g of a all over b minus a. And actually, that's the last one we'll do. We'll start off with that warm up on Monday and then finish the last 2 parts of this question to start off on Monday before we continue on. Again, you got your homework due on Monday night. If you have questions, feel free to stick around for a little bit. Otherwise, have a great weekend. Have a great day. I'll see you on Monday. Bye.